In this video, we're going to discuss blockchain oracles. What are they and how they serve an important role to connect blockchains to the outside world? Stay tuned.
In this video, I've decided to use the article from Binance.vision, which explains what blockchain oracles are very well and detailed, but not too detailed so as a person who's non-technical can actually understand it. Now, blockchain oracles are third-party services that provide smart contracts with external information. They serve as bridges between blockchains and the outside world. Now, for those of you that don't know what smart contracts are actually like digital contracts, just like a real contract, except it's digital. And it's mostly used in the blockchain ecosystem, hence why it's called a smart contract. Now, blockchains and smart contracts cannot access off-chain data, which means data which is outside the blockchain. Now, however, for many contractual agreements, it is vital to have relevant information from the outside world to execute the agreement. This is where blockchain oracles come into play, as they provide a link between off-chain and on-chain data. Now, oracles are vital within the blockchain ecosystem because they broaden the scope in which smart contracts can operate. Without blockchain oracles, smart contracts would have very limited use, as they would only have access to data from within their networks. Now, it's important to note that a blockchain oracle is not the data source itself, but rather the layer that queries, verifies, and authenticates external data sources and then relays this information. Now, the data transmitted by oracles comes in many forms: price information, the successful completion of a payment, or the temperature measured by a sensor. Of course, they're referring to hardware oracles here, which we'll be covering in a moment. Now, to call data from the outside world, the smart contract has to be invoked and the network resources have to be spent. Some oracles have the ability to not only relay information to smart contracts, but to send it back to external sources. Now, many different types of oracles exist, and how blockchain oracle operates is entirely dependent on what it is designed for. So this article is going to explain it here. These are examples of blockchain oracles. Okay, so we've got this example here, but instead of reading it, I would like you to read this as well. I will actually post a link to this article in the description with the example, but we're going to look at the different types of oracles that we have here. Now, what are the different types of oracles that we have?
Hey, if this is the first time we're meeting, my name is Claudio and this is CryptoChain, the channel where I do crypto news, reviews, tutorials, and interviews. So if you enjoyed this video, please hit that like button, click subscribe, and enable notifications to not miss the next video I upload that may interest you.
Now, blockchain oracles can be classified depending on a number of different qualities. We've got the source, which is, does the data originate from software or hardware? The direction of the information, is it inbound or outbound? And trust, is it centralized or decentralized? Now, a single oracle can fall into multiple categories. This is important to keep in mind. So, for example, an oracle that sources information from a company website is a centralized inbound software oracle. And the reason being is because the website is owned by one entity, so that entity can decide to take it down. Hence why it's centralized. It's inbound because it's coming from the website, right? The data is all gathered from there. And it's a software oracle because it's coming from a software. A website is a software. Okay, so here we've got more information on what are software oracles. So software oracles can interact with online sources of information and transmit this information to the blockchain. Now, this information can come from online databases, servers, websites, essentially any data source on the web. Okay, so that's very clear. It's all about digital. That's what software is, right? Now, the fact that software oracles are connected to the internet not only allows them to supply information to smart contracts, but also to transmit that information in real time. This makes them one of the most common types of blockchain oracles. Now, information typically provided by software oracles can include exchange rates, digital asset prices, or real-time flight information. Now, let's look at hardware oracles. So some smart contracts need to interface with the real world. Hardware oracles are designed to get information from the physical world and make it available to smart contracts. Such information could be relayed from electronic sensors, barcode scanners. Now, this is a really important one because we could really be seeing this happen, right? And other information reading devices. Now, a hardware oracle essentially translates real-world events into digital values that can be understood by smart contracts. Now, an example of this could be a sensor that checks if a truck transporting goods has arrived at a loading bay. If it does, it relays the information to a smart contract that can then execute decisions based on it. So you can find more information on the supply chain there for hardware oracles. Now let's talk a little bit about inbound and outbound oracles, as they were saying in the example above about the website. Now, inbound oracles transmit information from external sources to the smart contracts, while outbound oracles send that information from the smart contract to the external world. An example of an inbound oracle is one that tells a smart contract what the temperature is measured by a sensor. An example of an outbound oracle can be considered with a smart lock. If funds are deposited to an address, the smart contract sends this information through an outbound oracle to a mechanism that unlocks the smart lock. Now we've got the centralized and decentralized oracles. Now a centralized oracle is controlled by a single entity, as I was saying, the website, which is the sole provider, right? Now the risk with that, just so that I don't have to read through the whole thing, is that any malicious interface or a bad actor could have a direct impact on the smart contract because it is centralized, right? Now decentralized oracles share some of the same objectives as public blockchains, avoiding counterparty risk. They increase the reliability of the information provided to the smart contracts by not relying on a single source of truth. Now the smart contract queries multiple oracles to determine the validity and accuracy of the data. This is why decentralized oracles can also be referred to as consensus oracles. So this is an interesting term to keep in mind when researching different projects that are working with oracles. We've got examples like Chainlink, Band, which is the new hot one now. I will actually be doing a review on Band sometime soon because I find that project really interesting. Actually, I don't know how I've missed it, but it's been on Binance for a while. But there's also Teller too, so there's quite a few new projects in the space that are working with oracles to try to overtake Chainlink or maybe be like competitors to Chainlink. Now, some blockchain projects provide decentralized oracle services to other blockchains. For example, decentralized oracles that can also be useful in prediction markets where the validity of a certain outcome can be verified by social consensus. Now, while decentralized oracles aim to achieve trustlessness, it is important to note that just like trustless blockchain networks, decentralized oracles do not completely eliminate trust, but rather distribute it between many participants. So that is important because you do have a say, you've got a vote. You don't rely on one person or one source of truth. So that is important with decentralization, hence decentralized oracles. Now, the contract-specific oracles is one that is designed to be used by a single smart contract. This means that if one wants to deploy several smart contracts, a proportionate number of contract-specific oracles have to be developed. This type of oracle is considered very time-consuming and expensive to maintain. Companies that want to extract data from a variety of sources may find this approach very impractical. On the other hand, since contract-specific oracles can be designed from scratch to serve a specific use case, here's the key word, developers have high flexibility to tailor them to specific requirements. So there is a use case for this probably somewhere, right? So hence why they exist and why they're being created. Now, human oracles, sometimes individuals with specialized knowledge in a particular field, can also serve as oracles. They can research and verify the authenticity of information from various sources and translate that information to smart contracts. Since human oracles can verify their identity using cryptography, the possibility of a fraudster faking their identity and providing corrupted data is relatively low. So apparently human oracles are actually quite trusty, right? Now, the oracle problem, this is an important one because every pro comes with some con. This is what we have to keep in mind when it comes to anything in life, not only blockchain. So of course, oracles have a problem, right? So since smart contracts execute decisions based on data provided by oracles, they are key to a healthy blockchain ecosystem. The main challenge with designing oracles is that if the oracle is compromised, the smart contract relying on it is also compromised. This is often referred to as the oracle problem. Since oracles are not part of the main blockchain consensus, they are unfortunately not part of the security mechanisms that public blockchains can provide. The trust conflict between third-party oracles and the trustless execution of smart contracts remains a mostly unsolved issue. The man-in-the-middle attacks can also be a threat, where a malicious actor gains access to the data flow between the oracles and the contract and modifies or falsifies the data. So that is the scary part, right? Some bad actor getting in between when that data transfer is occurring from, say, for example, from a website, then that is a big risk with oracles, right? So that is something to keep in mind, that it does have its flaws as well. Now, a reliable mechanism that facilitates communication between smart contract and the original world is vital to the global adoption of blockchain. So hence why I was saying, as per the title of this video, why are oracles so important and so crucial to the blockchain, right? Because they're vital to the global adoption of blockchains. Else, who knows if blockchains will really be adopted, right? Unless we've got oracles. So hence why we have to thank projects like Chainlink, we have to thank projects like Band Protocol, and hopefully soon Teller too, who have developed a product and are still working on it to hopefully come up with these solutions to tackle these kind of problems, right? And then to actually see major companies, corporations use blockchain technology with oracles, of course, depending on their specific use case. So just to reiterate here, decentralized oracles have the potential to introduce safeguard mechanisms that could eliminate a lot of system risk from the blockchain ecosystem, while blockchain oracles remain one of the critical building blocks to be implemented in a secure, reliable, and trustless manner for the blockchain ecosystem to grow. So that was it from today's video. Let me know what you think of oracles. Are you bullish on oracles? What is your opinion on them now that you have listened to this video? Did you know about oracles before? Drop me a comment below and please let me know. And please don't forget to like the video if you enjoyed it. Thank you very much and see you in my next video. Take care. Bye-bye.